This is problem number 28 of the 2012 AP Calculus exam. For t greater than or equal to 0, the position of a particle moving along the x-axis is given by x of t is equal to the sine of t minus the cosine of t. What is the acceleration of the particle at the point where the velocity is first equal to 0? So let's begin with what we know. We're given x of t, which is the position function. It's equal to the sine of t minus the cosine of t. And we're going to be asked to find what is the acceleration of the particle. Well, it also says where the velocity was first equal to 0. So we've got to find the derivative of the position to find velocity. We'll then eventually go to the derivative of the velocity to find the acceleration. And that's where we're headed. So let's begin with velocity, which is equal to the first derivative of the position. And the derivative of the sine function is cosine. And if I subtract and take the derivative of the cosine, I get negative sine. And if we subtract a negative, it can become plus a positive. Now, it says it mentions that we want to find when the velocity is first equal to 0. So we're going to set that equal to 0 and solve. So the cosine of t plus the sine of t, we want to know when is that 0? Well, the best way for me to tell is just to look at the unit circle. And I know there's values at which I have the same term, or x and y terms, but with different signs. And that's what we're looking for. We're looking for a positive of the value and a negative of the value so that I get 0. So in other words, we're looking for opposites. Well, I know that I get terms that are the same when I have terms such as pi over 4. I'll get the square root of 2 over 2 and the square root of 2 over 2. But these are not opposites. They're both positive. So let's go to the next one that's like that, and that would be if we go from 1 pi over 4 to 2 pi over 4 to 3 pi over 4, we'll see that that coordinate is a negative square root of 2 over 2 and a positive square root of 2 over 2, and that's going to give me 0. So again, if I had the cosine of 3 pi over 4 plus the sine of 3 pi over 4, I'll get 0. Because, again, 0 would be equal to the cosine of the cosine of 3 pi over 4 would be negative square root of 2 over 2. And the sine of 3 pi over 4 would be the square root of 2 over 2. And opposites would give us 0. So that's what we were looking for. Okay, so I found that my value is 3 pi over 4. Now, we might think, well, there's another one that would do that. I could have something over here in this other quadrant where I can go around the circle 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. And I'm thinking, well, that would give me a square root of 2 over 2 and a negative square root of 2 over 2. That would give me 0. But in the directions it says the point at which the particle first equals 0. So we're only wanting the 3 pi over 4. Okay, so we found the value that we want, 3 pi over 4. Now we need to take the derivative once more and find the acceleration, and then substitute in that value of 3 pi over 4. So we said the velocity was equal to the sine of t plus the cosine of t. I think that's what we had earlier. Let's make sure. Oh, I think we had it as cosine plus sine, but the order will not matter. But I'll put it back like it was so that we have it. So the cosine of t plus the sine of t. And you could have had it the other way. Now, if I take the derivative, that will be equal to the acceleration. And so the derivative of the cosine is negative sine of t. And the derivative of the sine is cosine. So I'll get cosine of t. And now we're going to substitute in the value. We're going to have a of 3 pi over 4, which will be equal to negative sine of 3 pi over 4 plus the cosine of 3 pi over 4. And let's see what that's equal to. I'll have a negative, and then let's look at our unit circle again. And we look at the 3 pi over 4. And we know that's a negative square root of 2 over 2 and a square root of 2 over 2. The cosine is the first one, the sine is the second. So I'll have a negative, and the sine is a square root of 2 over 2. Plus, the cosine is the negative square root of 2 over 2. So if I have a negative square root of 2 over 2 and then added to another negative square root of 2 over 2, I'm going to get negative 2 square root of 2 over 2, and the 2's are going to cancel, which leaves just the negative square root of 2. And that is my acceleration at 3 pi over 4. And that's our answer. The negative square root of 2, that's letter A. Letter A.